Hello everybody and welcome back. We're on question number 24 from the 2003 8th grade level Gauss competition. So second last question, one of the part C questions, so should be challenging because it is worth 8 marks. But let's see. In the diagram, ABCD is a square with 25 centimeters squared for its area. So immediately I realize, oh, that means that AD and AB, because it's a square, they're going to be the same length, and they have to both be 5. Because in order to get an area of 25 for a square, you square root it and you get the side lengths of 5. Okay. If PQCD is a rhombus, so a rhombus is a parallelogram where all the side lengths are the same. So I know that PD is the same as DC, and hey, DC is part of the square, so it's side length 5, so I know that the rhombus has side lengths of 5 as well. So this particular rhombus has area 20 centimeters squared, and it's another area of the shaded region question. Okay. We had one of those a little while ago, question 19. So, as I said then, and I'll say again, when you're trying to do a shaded region style question, it's important to realize the particular area you're looking at as sort of a difference of areas that you know or a sum of areas that you know. So when I take a look at this one here, it sort of looks like the square with part of the rhombus cut out, but not a reliable part, not one that I can easily work out. But that's still something I could try and do. I could create this point here on line PQ, where PQ intersects BC, and try and figure out the resultant, let's call that R, try and figure out the area of PRCD, and then take that away from the 25 that is the square. That'd be a perfectly valid way to do that. I'll show what I'm talking about as I draw this picture in the notebook. Well, first we have our square, and then we have our rhombus. Okay. And hidden back here is BC, which is being covered by the rhombus in the picture. And we have A, B, C, D, and P and Q. Okay, and I'll shade the area in that we want in yellow. Okay, so one thing we could do is realize, hey, if we take the big square, which we know the area of is 25, and subtract off this blue part, we'll be left with the yellow part. And that worked just fine, but then that leaves us with the unfortunate task of trying to figure out the blue part. You can certainly do it. You just need to work it out. That's not the way I'm going to go about doing it. What I'm going to do is I'm going to say, hey, if I just extend PQ so that it hits over here at A, I'm left with a right angle triangle and a rectangle. If we call this R and maybe this S, we're looking at ABSR plus the triangle DRP. And so maybe I can break those down and work out those areas. So what I've done is I've recognized my shaded area as the sum of two simpler areas that hopefully I should be able to realize. Okay? We got a rectangle. Well, hey, I know the formula for the area of a rectangle. It's length times width. So if I knew, well, I know how long AB is. That's 5. I've already explained that. But if I knew how long BS is, that's the little height of our rectangle, I might be off to a great start computing that area. Same if I knew, so this triangle is left, this right angle triangle. Well, formula for the triangle is 1/2 base times height. If I knew RD and I knew RP, those are base and height just fine because it's a right angle triangle. You'll get the same sort of thing if you were to cut up this bigger, wider area. You'd get a right angle triangle and another square as well. But this is the way I first saw it, and so this is the way I'm going to do it. So, my shaded region is the rectangle plus the right angled triangle. So now it just falls to us to figure out, well, what are these? What are these areas? Okay. So, well, let's go label some numbers. I know already that my square has side length 5, and because it's a rhombus, I know the sides of the rhombus are also going to be 5, because DC is 5, and that's one of the side lengths of the rhombus. Okay. And I notice that DP here then is 5, so already I'm thinking this is probably a 3, 4, 5 triangle. It's a right angle triangle here. And usually triangles with hypotenuse 5 are going to be 3, 4, 5, especially on the younger year contests. 3, 4, 5 is one of those Pythagorean triples that I recommend that you know. Another good one is 5, 12, 13. Okay, Pythagorean triple, because 3 squared plus 5 squared is, 3 squared plus 4 squared is 5 squared. Okay, but we don't know that that's the case. We think that that's the case, but we don't know it. So, other information that we're given, we used the area of the square to get the side lengths of the square and then the side lengths of the rhombus. One piece of information we haven't used yet, if we go back to the question, is that the rhombus has area 20 centimeters, 20 centimeters squared. Now, they usually give you exactly the information you need to solve the question, and if we haven't used a piece of information, we should start trying to look for ways to use it. Okay? We used the area of the square for 25 to get all these wonderful side lengths. Can we use the area of the rhombus? Well, how do we figure out the area of a rhombus? Well, rhombus is a parallelogram. And for parallelograms, I can get my green here. For parallelograms, the area is the base times the height. So 20 centimeters squared is the base times the height, but that's 5, the base of DC, times the height of h. Not that hard to see. H is going to be 4 centimeters. But h is how high up P is from DC, but that's exactly how high up R is from D. So we're left with 4 here. And then what's left over for the height of my rectangle? Well, it's 5 for the total length, minus 4 going from D to R, so what's left from R to A? A length of 1. So my rectangle has a base of 5, length AB is 5, and a height of 1 centimeter. So length times width, we get 5 centimeters squared. So now all that's left to do is to figure out the area of this triangle, but it's got a 5 and a 4. So by the Pythagorean theorem, which I'm not going to write out right now, you should know that one already, we get that this length here, RP, is 3. Okay, we can rearrange. It's a very nice triangle, 3, 4, 5 triangle. And that means that this right angle triangle, why it's 1/2 base times height. Well, the base is 3 and the height is 4. So that's 1/2 times 12. That's going to be 6 centimeters squared. So what's the area of the shaded region? That's my rectangle plus my triangle. That's 5 centimeters squared plus 6 centimeters squared. Should be an answer of 11 centimeters squared. Now let's go and check. Is 11 one of our answers? Yeah, it's C. So we'd bubble in C and we'd move on. And you'd get 11 centimeters if you cut it up the other way. If you had done what I originally suggested and said, figure out this segment of the rhombus and subtract it from the overall 25, it's going to be 14. In fact, we can sort of see that here. We'll get a height of 4 and a 3 here. And if there's a 3 here, we'll have a 2 left here. So 2 times 4 is 8 plus a 6. That's going to be 14. And what's left over from the 25 is 11. So you can do it both ways. Alright, so we'll flip the page again, and we are going to be ready for question number 25, the last question on the contest, and I hope to see you there in the next video for that one.